That's computer. So it's recording, right?
Yes, it says recording in the top left.
Yep.
Okay, that's good. So let's begin.
Create a tree using the array below, where k equals true. Draw your tree on paper and upload to this question.
Okay, yeah,
Work
I'll
as a
write it.
team, work together in the building. Oh, in building. Okay. Okay. I was confused.
Yeah, we all gotta find a building, go to it, guys.
Run on campus real quick.
Yeah, so I'll put this in the doc. Yeah, and then
Okay.
I'll write this one.
I will work on paper, but do you think we need, like, would it be easier to just take a picture of it on paper, or do you think it would be easier to do it on Google Docs?
Well, it says to draw it on paper.
Oh, okay. Never mind. I missed that.
So I think we're just gonna take a picture and then like upload it to like Google Drive.
Sounds good. Let me just go grab a notebook.
Yeah, I got mine right here. I'll handle the first question.
So it's 58 at the top. Does it say what type of tree it is? Do we know which one is on the left and right?
We just go from, yeah, the first node's on the left.
Right.
That's the notation. And then the k equals 2, so it's a binary tree.
Right.
(2311). So since k equals 2, so the first node is going to be the one on the left, which is 58.
Yeah. I have it drawn out if you just want to look at it.
Oh, okay. Yeah.
Is it getting blurry? Yeah, it's getting blurry. Hold on, let me turn the filter off.
Yeah, but 58 should be at the top, right? Then
Yes, 58 at the top.
Then 30 is the next node on the left. Then we can go to the next node, which is 90, which is going to be on the right. Then 74 is going to be the left child of 34 or 30.
Mhm.
Then 80 is the right child of 30.
Mhm.
Then 22 is the left child of 90.
36, the right child of 90.
Yep.
And then 69, left child of 74, 23, right child of 74, and then 11, left child of 80.
Yeah.
Um,
There we go.
I don't know if you can read that, but
Yeah, that looks about it.
I think we got the same.
Yeah. So I'm going to stop sharing my screen and I'll put the next, actually I'll put the next problem down, but then I
Okay.
think someone else needs to. Yeah, and then I'll upload mine to the Google Doc.
Sounds good.
And then hold it.
I can do the next one.
Here we go. Let me write it down. Yeah, I'm gonna stop sharing and upload.
No empty spaces, right? I don't know if the formatting transfers over.
No empty spaces. I don't think
In
there's
the
any.
array.
I don't think there's any empty spaces.
Okay,
Yeah.
so k equals 3, so it's 3 children. So 81 at the top, with 50 leftmost child, 76 middle child, and 1 right child of 81. And then the left child of 50 is 33, 34, and 93. And then there's 74, 39, 89 for 76. 74, 39, 89.
Yeah.
And then the children of
3.
1 are 86, 81, 80, 86.
Yeah.
81, 45.
Yeah.
My drawing's really bad. We might have to use somebody else's. And then the children of 33 are 54 and 1, and that's where it stops. But that's what I have. Can zoom in a little bit.
Yeah. So there should be 3 nodes.
Oh, if I stop sharing my screen, you can see easier.
Yeah. So it should be 50, 76, 1, then 33. What is it? 34? Yeah.
Yeah, that's 34. I have a bad handwriting
Yeah, can you like draw like an extra dash upward on the right stick?
on the right stick.
Yeah, and the 34 on the 4 part.
Oh, I see what you're saying.
Yeah.
Yeah, I wanted to just rewrite this for submission. It's like really messy, but
Yeah, 34, 93, 74, 39, 89. Yeah, then 86, 81, 45, then 54, then 1. Yeah, seems good. I'll upload the next question. Mm. So I think this one we're gonna have to traverse. Looks like a traversal. Let me see. Um, Looks like I have to upload it, so that's definitely something. Let me get rid of this one.
all the questions are that easy.
Okay, that's the tree, right, on the second page?
Yeah. Here,
Okay.
I'll kick 3 down.
Okay, we're prefixing it, so PLR. I need a pencil, okay. So we're gonna process 0016 first. And then it's PLR. Okay, then we're gonna move to the left, and then we process 0014.
Mhm.
And then you go to the left, and then we process 0009.
Right.
And then there's no right, so then we move back up. There's no right, we move back up, and there is a right. And so then we're gonna process 0027. And then we're gonna move to the left, so we process 0026. And then there's no left and there's also no right, so we move back up. We already did left, so we're gonna move to the right, and then we're gonna process 0048. And then we're gonna move to the left, and then we process 0040. There's no left, there's no right, we move back up and move to the right, and then we finally process 0049, and then that should be it.
Oh yeah. For all the other questions, we can write this on the Google Doc. So yeah,
Sounds good.
there's no file upload.
Okay, well
We're
then
not
let me
submitting it.
just write it then.
Sorry about that.
I'm putting the picture of the tree on the
Yeah, I'm going to upload mine. Let me upload this to my Google Doc. Okay, wait. Let me see. Yeah, but drive, folder, drive, 1, 5, save here. Then this is lab CSCE 1 lab 5 Q1.
I uploaded mine on the doc. Hopefully that's good enough. I can take another picture if that's not good quality.
Yeah, I'm going to.
It looks fine.
Yeah,
Nice.
I'm going to upload mine. Okay. Let me do this. Yeah. My iPhone doesn't have, or well. Hold on.
We can just, oh, we can't do multiple questions at the same time. Never mind.
Yeah, I'm almost done with this, but let me. Yeah, and then I should be able to upload this format. Yeah, sorry, my iPhone. It was like in a .heic that it sent to me.
Yeah, I know exactly what you're talking about.
Is this good or?
Let me check the doc. Yeah, you can read all the numbers, so I think we're good.
Okay, yeah, and then I'll get the next problem up here. I'll put these all on one page or separate pages. And then I'll get problem 4. So it's going to be another one of the infix, or it's going to be infix this time. And then it is this. So for the infix, we're going to go all the way from the left.
You're not sharing your screen, by the way.
Oh, oops. Yeah. So for problem 4, it's the infix for this tree, which is, I think it's the same tree.
Mhm.
So we go all the way left, then we print, then we go right. So we go all the way left, so that would be 009. And then we print it. There's nothing to the right of it. Then we go back up. There's nothing. We print it. 0014. There's nothing to the right, so we go back up. We print this, which is 016. So that's good. Then we go to the right after we print this. And then for this one, we go to the left. And that's 0026. There's nothing to the left, so we print. There's nothing to the right, so we go back up. And then since we already went to the left, we print this. Then we go to the right. So that should be 00.
It'll be 40 next because you're gonna hit the
40.
leftmost node.
Yeah, you go to the left first, then nothing to the right, so you go back up. And then you go to the right, there's nothing on the left of that, so you can print that, and that's it. Right?
Yeah, looks good to me.
Okay, I'll get the next one.
Yeah, I can do the next one.
Yeah, it's the postfix of the same tree.
Nice.
Problem 5, let me delete that, like that.
I hope we don't have to do actual code because I didn't look at the code for the tree. I guess it wouldn't be too hard. It's just a linked list, but
I don't think there's any code. It's just,
nice.
I think actually the next 2 questions are research questions. Like you go search up different trees.
Nice. Okay. So postfix, so we print at the end of it. So 0016, we go left. Oh, well, let me just write it out. It's like left, right, print, right?
Yeah.
So 0016, go left, 0014, go left 0009, because there's no children there. And then it goes above, nothing on the right, so 0014. And then we go all the way at the top. Then now we go to the right side. So 0027, left side is 0026, no children, so 0026. Go back up. We're going right side now, so we go 0048. 0040 has no children, so that's the first one we're going to print.
Yep.
And then we go back up to 48, and then we go right side, which is 0049, and then 0048 is print because 0049 has no children. So then we go above. Right side is cleared for 27, and then we go above for
Yeah, it looks good. And then
all right, let's get started on the 2 easy ones, or maybe these are the hard ones.
Yeah, this one and the next one are research, I think. So,
I can keep my screen shared.
so, yeah. So we have to look up what a full binary tree is.
Yeah, and it looks like we need two separate sources.
So,
Okay, so every node has either 0 or 2 children. Okay,
yeah.
here, before I do that, definition source. Because he wants a different source if it's for the application. A full is a tree with
So I guess we need to think about the applications of this.
Well, I thought he wanted us to research it.
Oh yeah, research it. And then come up with a different example is I think what he wanted, right?
Come up with a different example. Cite your
Yeah.
source, but without using the same sources. No, I think so. I think the sentence is saying don't use the same source that you used for the definition. I don't think it's saying use a different example than the one in the source, or am I reading that wrong?
Well, it sounds like there's only one source is what it's saying.
Yeah, there's only one source, but then they ask you to like
Oh.
describe how you would use the tree, and I assume you can't use like the example that whatever your source gives.
Yeah.
Oh, I read it wrong. Our source didn't even give an example.
Yeah.
Oh, well, here they said it's used in Huffman coding. Yeah, the one immediate example use case I found was that it said you can iterate through it just by doing like indexing. So you could do like +1 because like at every node you're at, like index I, then you can just do +1 to go to the children of it because there's no empty spots or no branches with only one child. So it's easy to iterate that way, but
Is Stack Overflow a good source for applications of binary trees?
I think so. I mean,
Okay, here y'all go.
is it in the Zoom chat?
I'm about to put it in there, and it's in there. They gave several, so I was like, this is nice.
Okay.
So yeah, they're used in like 3D game development for object rendering, used to store router tables for bandwidth, and then the Huffman for like compression algorithms for different file formats, and then in cryptography. So there's several different applications.
Yeah.
Yeah.
I think it wants the full binary tree. But yeah.
All right, we'll go a little more in depth with that then.
Wait, is it a
Wasn't just
full
a full
or?
binary tree just a type of binary tree? Like it's only the state of the tree and not like a physical thing. So I'm like, I don't know what application would require that your binary tree has to be full.
Yeah,
So much
that's,
so that like you can just use a binary tree and you'll end up with a full one at some point.
yeah. That's I guess what he wants us to find out.
So should we rate that or?
I'm still trying to find use case or like you basically where full binary where when are full binary trees used. It only ever shows up like applications of tree data structures and not full binary trees.
Yeah, I think this is just a subset of a binary tree. Like there's also complete binary trees where everything's pushed to the left, but like I don't think there's an application where you only have to use that kind of tree.
Well, what's the next question? Maybe that'll tell us.
The next question is about ordered trees. So I'll put it in the Google Doc if you want to focus on that.
No, I was just wondering because if
Oh.
it's like the same question but with a different type, then maybe they want us to find specific.
Or it's a very different question, I think. Here, let me.
Oh, that doesn't help.
Here, I pasted it if you want to move on to that one. So there are other trees called ordered trees. So we're gonna Google ordered trees. Yeah.
Oh, the next question's already posted. Okay.
Yeah. It's similar, I guess, that we need to find what applications it's for. I think we can use the same example, just don't copy it word for word.
Yeah, but I think the previous question says, what can this type of tree be used? So I think we need to find specific examples of when full binary trees are used exclusively. Okay, wait, which question are we working on?
Which do y'all want to work on? 6?
I would rather just finish the thing. Is that what
Okay.
6 is? Yeah,
Yeah,
okay, yeah. Let's
I think
just
we're
find
going.
an answer for 6.
Okay, so I guess we'll just have to keep doing research. Yeah, mostly what I can find is just stuff based off of like calculating the nodes or leaves based off of given.
Yeah, I guess it would help if, actually, I don't know, where would you even use that exclusively?
Would like a true false table fit under a full binary tree? Because you can only ever have true or false. And if like you reach a point, you don't have any more nodes.
Yeah. Yeah, I guess
Like
that's
I don't
all.
know where that would fit broad pick. That's like the only thing I can think of that has either two nodes or nothing attached.
Yeah. Yeah, I think that makes sense. We could use it in truth tables, but also like, what does that look like exactly? Like when are we doing? I guess that would be like for if blocks. And I don't know if you would have that in a tree though, but
Yeah, it's very difficult to come up with stuff that fits a full binary tree.
yeah.
That's like the only thing I can think of, but no broader application.
Game 2. Oh, actually, yeah. You talk
They're
about
called
them.
decision trees. I found like their actual definition for predictive modeling and statistics, data mining, and machine learning. Let me see if I can pull up an image. That's a Wikipedia article, not the greatest source, but just to get the point across and like what you could actually use that for. There we go.
Yeah.
Okay, I think that qualifies as a full binary tree.
Yeah.
Some of the nodes are like 3 though.
Some of them
But
are
yeah,
Mean
three.
three.
or yeah, in the diagram. Or if you look at the one,
Oh, the first one.
yeah. Actually, you're talking about truth tables, and I think the one from the original website actually talks about that. I'll put it in here. But yeah. So it's called the BDD.
Well, we can't use that then though, since it's in our original source, unless we change our source.
Oh, okay.
If we can just change our original source to something else though.
Yeah. I mean,
we can use that. But I mean, but the decision tree is also the same thing. It's basically the same thing. So yeah, I guess you would use it in like in a lot of places because it would, well, the idea, the thing that comes to my mind is like in games there's like dialogue choices or whatever, so it would come up there where each choice would lead you into a new branch or whatever.
yeah.
But,
So I guess we could write that down.
yeah, I'm writing it in the document right now.
Yeah, just be like you could use a decision tree, but then like specify that this is a binary one, so it actually is 2 and not 3 leaves or more, like this decision tree up here in the top right.
It can be like a decision tree with a truth table. So you're like forced to make either one decision or another one, but not like multiple.
Exactly.
Oh, what was the thing called?
Decision tree.
Decision tree.
Using the truth table. Yeah. And then
Sorry, you were saying?
oh, yeah. Yeah, my train of thought got lost.
Um, oh, he said one paragraph, so.
Yeah.
Okay, I think that's fine.
Yeah.
Is there? Yeah, that would be a binary tree, right? Oh, we're not sharing our screen. That's a problem.
Yeah.
Yeah, so to the grader or whatever, we were typing this up on Google Docs, and that's what everyone was staring at.
Yeah.
Okay. Yeah, that looks fun.
Yeah.
Yeah.
Okay.
Okay, let's move on to the next one. There are other trees called, oh wait, we need to get a source.
Yeah, that was the source, right?
Well, actually, yeah, this decision one came from,
Yeah,
okay,
the grocery store we made up.
right. There are other trees called order trees, Google order trees.
Yeah.
You'll recognize the first one. Oh, we just did that. Okay. Wait, I'm confused. You'll recognize and skip one of them immediately. Pick one of the other two ordered trees and answer the question below. What? What does that mean?
I think it means that we should have already done one of these trees as a problem. Oh,
Oh, maybe
yeah,
it's
you
this
see the
one.
one on the, or go back, the cs.lmu. I'm pretty sure that was in the notes, so I think we skipped that one.
Yeah, I'm on the website for it now. We did, in fact, do it and then skip it.
Okay, so we gotta take two of these trees that we haven't seen.
Two?
Yeah, it says pick one of the, or well, pick one.
Yeah. One of the other two.
I mean,
What is one of the other two?
There are technically two more trees on the website where you can get the original picture, but they're not actually labeled with like data. They're just dots on a tree. If that makes sense.
Why not just give us this link then though?
I don't know, but there's only like two more trees on there, so.
Yeah. I guess we just do this one then. Fibonacci tree or binomial tree or K-array tree.
oh.
Oh, we already did the K-array. He wants us to do either a
Okay, that's what,
binomial tree or a Fibonacci tree.
okay,
Okay.
that's what he wants.
That was a little confusing. That should probably be something we should bring up in the survey or whatever.
Survey.
Okay. To be honest, both of these sound not fun. Which one do you guys prefer?
Just do the Fibonacci one because why not?
Okay, fair enough. Okay, in your own words, describe what the ordered tree it is that you picked. Find and cite several images of that type of tree. In your own words, describe how it works and determine what applications it could be used for. Finally, find and cite any online interfaces the ordered tree that you picked that you would use if you had to help a classmate understand the ordered tree that you picked. Okay, well, let's first
Search it
try
up.
and understand it.
Yeah.
Oh, I mean, we can switch it. Oh, let's just read up on these two and see if there's one that would be easier than the other one. All right, so the binomial tree consists of a node with k children. The first child is a root of a bk minus 1 tree. The second is the root of a bk minus 2 tree. Okay. Oh, so you're just going down all the way to 0, basically, with the binomial tree.
Yeah. Yeah, so the left tree is one longer than the right tree, has one more child.
Okay.
Yeah.
I'm confused as to what the Fibonacci tree is, to be honest.
So there's 3 different cases. So if there's 0 children, then, or well, I guess it depends on what k is. If k is 0, then there's nothing in the tree. If f is 1, there's only one node in the tree. If it's like 2, so that would mean, I guess you'd have a tree that starts at length 4, and then you'd have a tree to the left with length 3, and then
I
a
found
tree
an
to the right.
example that might help you describing it like visually.
Yeah, I think we should probably just search it up and see what it looks like.
That's what I was looking for, the trees. I'm just a very visual learner, so people describing things would not help me until I see a picture. So here's the
Yeah.
picture in the chat.
This is not what I meant.
It's the same thing, it's just upside down. Yeah, that. Click on that third one and it should take you to like an example.
Okay,
But
I get
yeah,
it.
the root node is always going to be the largest and the last like Fibonacci number you have.
Oh, so you build the Fibonacci sequence this way.
Yeah.
3 plus 2 is 5. Yeah.
Okay.
So
Yeah,
which
which one
tree
do you
do
guys want to do?
Can we search a binomial tree and see what it looks like? Um,
It's nice to look at.
yeah, I don't know what it's saying.
This is even more confusing, I think. Do you guys just want to do the Fibonacci one?
Yeah.
Yeah, I told
Okay.
y'all. Why not?
Yeah. Okay. In your own word, describe what the ordered tree is that you picked. Does somebody else want to do this one? I can stop sharing.
Okay, yeah, I guess I'll do it. Yeah. So for this one, I guess we'll do number 1. So
Oh, I get the
the
pictures for 2.
yeah, the Fibonacci tree is a tree that builds a Fibonacci sequence using a binary tree data structure. I think that's pretty much in our own words, right?
Mhm.
I don't think it said it on there, but yeah. But yeah. So the root node is the current value of the Fibonacci sequence.
We just put this down here.
Each child is a previous node in the Fibonacci sequence.
Oh, now you can't see it. Okay, never mind.
Yeah.
Okay. So find inside several images of that type of tree.
So probably like 5 images would be good.
Yeah. Yeah, here, let me,
Yeah, I'll go search up some.
yeah.
Okay, that's not it.
Yeah, Fibonacci being so applicable is kind of hurting the search for Fibonacci trees. Because I'm just finding a lot of pictures with trees in them that have Fibonacci sequence related to them.
Yeah, let's try and find different ones. So here's one for 13. Or well, I guess it's from Wikipedia.
Yeah, unfortunately, a good chunk of the good ones are like Wikipedia.
Okay. You think we can use Wikipedia? I mean,
I want to believe you should be able to.
actually, I don't
That
know
and
what this
Stack
is.
Overflow keeps giving me more and more Fibonacci tables. So I'm so tempted to use it.
Yeah, I like this one, but I don't know if we can use it or not.
I'm not sure if this is correct because I don't know what it's adding. Because 8 plus 18 is not 13. Here, maybe I'll give us.
I think this is different. I think a Fibonacci heap is a different type of thing.
Is this better?
Okay, let me put
Okay, well,
here.
I think we already have a 5, but we'll just use this, I guess.
Oh, I copied a picture and then proceeded to copy the source and forgot I couldn't do both.
Oh, oof. Yeah. Here, let's go back to searching.
I mean, I feel like we can justifiably just get 3 and call it a day. There's 2 already, so just one more.
Yeah. Oh, that one's good. The Geeks for Geeks one.
Where?
Oh, never mind. It's something else.
Yeah, it's a heap.
Damn.
Yeah, so here's one for. I guess someone made this for their data structures class. Do you think we could use it?
I feel like that's fair.
Okay. Yeah.
So we're good.
Okay.
Yeah, I put mine in the chat, but I don't know. It's another 5 though, so I don't think we can use that.
Yeah. I think this is fine since the first one had a bunch of trees already.
Okay.
Yeah, and then I'll make sure to cite this. Okay, there we go. And then I guess I'll put source. And then what was question 3? Describe how it works. So
Well, you just add the numbers in the branch to, well, you add the numbers on the left side. Wait, is it right side? Can you go up to the pictures again?
yeah.
Basically, the 2 leaves will multiply or add to get the parent node, and then you're just going to keep doing that. So every time you make a new node, you have to make, like a new parent, you have to make another child.
Yeah, so the node on the left is the previous child, and the node on the right is the second previous child. So for example, like 3 is 2 plus 1, 2 is the previous one, and 1 is 2 terms before it. And so that's how it's made.
Oh, I see what you're saying. Okay.
Yeah.
Yeah, so each child is -1 or -2 then,
Or it's
except unless it's,
yeah, the one on the left is the previous one, which is, I guess if you have a k, or if you have n terms, then the 2 right here would be n minus 1, and then the 1 over here would be n minus 2, like for the index.
right. The issue is for when the number is 1. If the number is 1, then it's just the children would just be 1 and a 0.
Yeah. So
I
yeah,
guess to
I'll write
describe
down.
that, we can say like each parent is formed by adding up its two children.
Yeah.
Um,
Yeah, so the Fibonacci tree works by having children that add up to the parent, right? And so the left child is the previous term in the Fibonacci sequence. Then the right child is the second previous term. Is that correct?
well, you could say is
Well, the previous term of the left child,
yeah,
right?
yeah. That's
Previous
what I was
term.
trying to say.
Yeah. And then there are also two edge cases. If the given given n is the index or number of terms in the Fibonacci sequence, then if n is 0, then there's no tree, right?
Yeah, if n is 0, it's an empty tree.
Yeah. If n is 0, then the tree is empty.
And for this one, it's if the tree itself or the sequence itself is only 1, or if we are at a branch where it's 1, then the children would be 1 and 0.
Yeah. Tree has one node with a value of 1. Yeah. That should be
Well,
it.
it also, I mean, shouldn't it technically also have a node with 0? Or
Wait.
is it?
I think we have two different definitions because the one that you pulled up with like the ordered trees, like it said there was nothing here, but then this has a 0 on it.
I think that's just their way of representing the graph, maybe. Because also, if you scroll down,
Yeah.
the last picture, for when it's 1, it just has 2 zeros, which doesn't make sense in the Fibonacci sequence because you're supposed to have 1, 1, 2, 3, 5, 8 is this
Oh, yeah.
Fibonacci sequence. The Fibonacci sequence is not 0, 1, 2, 3, 5, 8.
Yeah. Why don't they do that? Let me see. Oh, wait, what?
This is, I don't think we should use this source. I
Yeah,
think we need to find another one.
I don't know what they're doing. Okay.
Fibonacci tree. I'll just do it. Okay, I think we can actually use this one.
Which one?
Uh,
Oh, did you put it in the doc?
Yeah, I'm about to. I'm just gonna replace the one that has the wrong,
Yeah.
and then let me update the source too real quick.
Yeah, so this tree is just upside down, so that's okay.
Yeah, but the numbers are, and it's actually the Fibonacci sequence, so we should be okay.
Yeah. And then presumably there's zeros at the top.
I know we haven't gotten to like part 4 of the last question, but I went ahead and tried looking up stuff. So I'm going to put a link. It's not like the definitive answer, but you can kind of like interpret its usefulness with this.
Yeah.
Got it.
Basically.
So yeah, we can search it up.
And then he'll like describe why Fibonacci numbers are important, which I assume is why the tree itself is kind of important. It's not in that, but it's in the next one, whoever answered him. So mostly the first and the third one. And it talks about like the big O.
Oh, yeah.
So I assume they're one of the easier trees to sort through, or faster trees to sort through.
Yeah. Yeah, so I guess, yeah. So I guess how do y'all want to word this? So the Fibonacci tree is useful because it can easily be so they gave 4 reasons, right? One of them was like it's easy to teach recursion. Then the other one, it's easy to generate and it's fast to look up.
Yeah, it has one of the like the faster lookup times. And it's kind of used as like the basis for what is like a good runtime for a program to search through a tree, basically. Like this is the optimal runtime.
Yeah, so for example, if we wanted to find like, what is it? If we generated a binary Fibonacci tree with like 100 terms, we could easily, it would just be like ON or something. Or, yeah.
Well, you can just say like, shouldn't it always just be ON? Because it's just recursion. So
Yeah.
So like searching through the tree of a Fibonacci tree structure would just always be of a notation ON. And like Jordan was saying, it would also be like the ideal version of like any binary search tree is what you said, right?
Mm-hmm.
Yeah.
Oh,
So,
maybe you should call it like the ideal runtime.
And then I'm
isn't
also
a
going to
binary
put this,
search tree like O login? Or did I misread?
I think so, but I'm also going to put this PDF in there. It's a lot of discussion about like optimal runtimes of various, file lookups and transfers and stuff, but he does have a discussion on Fibonacci search trees on page 7.
Okay.
I don't know exactly if he answers the question, but I saw Fibonacci search trees and I was like, okay, well, this seems kind of important, kind of relevant.
Yeah. Oh, wait. I think it what was it? Let me reread this. Get the first n terms. Oh, okay. So you can get any. So to get the first n terms is ON, but any arbitrary term is O log n. Okay.
Oh, my fault. So that paragraph we wrote is supposed to be O log n, not ON.
Yeah. So yeah, but that makes sense for a binary search tree since you're cutting it in half each time.
Mm-hmm.
And then what else?
And then where they say like it's applicable, I guess you could do file lookup, because I know that was one thing that this person discussed in his paper. Let me see if I can
Yeah,
find
and then
it
we can
again.
yeah, we can also talk about how it's easy to generate. And efficient to generate. the Fibonacci tree. So yeah, I think that's good, right?
I think that's fine. Should be enough.
What was question 5 then?
Find and cite any online interfaces of the order tree that you pick that you would use if you had to help a classmate understand the order tree.
Okay.
That's a
Interfaces.
mouthful. I don't like that, how you phrased it. Okay.
Is there like an
Interface.
online Fibonacci tree?
Oh, so like if I went online and was trying to build a Fibonacci tree, is that what he's asking for?
I think so. I don't think this is.
It says heap, so
Yeah, that's not it.
you maybe try Fibonacci tree visualization.
Yeah, I'm pretty sure Wolfram Alpha has one.
Oh,
Let me put this in here. I don't, it's kind of ugly, but maybe this.
oh,
I put in the chat.
yeah. Let me see.
Oh, that is kind of ugly.
Yeah, it is a little ugly. Like it gets the job done, but I don't know if I'd use it.
I mean, if it works.
Wait. Oh, does it not have the numbers on it?
Um,
Yeah, I don't think it has the numbers on it. Is the issue.
oh, that's not good at all. Okay. Never mind, you can drop that.
Their Fibonacci tree generator.
Yeah, everything seems to like Fibonacci heaps, but not trees.
Rip. So do you think I could just send them a website instead? Because I'm not even sure that there is a.
Try.
Okay, that's not what we want. Yeah. I'm going to presume that what they want is rather than like something interactive. Because it just says online interface.
Mm.
Yeah, can we go to like the first one? Yeah, the one with the Berkeley. I think the Berkeley one is pretty good since it has all the
Maybe-
images.
Yeah, I think maybe we should put this one and the Wolfram Alpha one. Just in case if they meant something interactive, we at least have something that fills that
For sure.
requirement.
Yeah. Where is it? Yeah. So what was it? So okay. For the online interface, we found the following website to be the most useful for understanding Fibonacci trees. It gives both a good explanation and plenty of example images. Yeah.
And we can also just say the one link for like something like a demonstrated one, but it doesn't really have numbers though. So if you guys don't want to do that, it's chill.
I think the first one's the Berkeley one's fine because I don't think we should have the other one because I'm not sure it's going to help at all. Like, I guess it looks nice, but like, if you can't see the numbers, then
Yeah.
yeah.
All right. It's cool. Do you guys just want to turn all this in? It's like a bit messy though.
Yeah,
I think so.
I'll start turning in. Yeah, I'll start uploading all the stuff, the quiz. Yeah. So that file is, if I go to my downloads, this would be this. photos. Yeah, that's that.
Mhm.
And then I will have to download the, I'm going to close all these tabs. And then I'll download this.
It might be easier to just take a screenshot of it.
Oh, yeah. Looks good. And then I'll save it. This was Q2. And then I'll upload this to the quiz. Yeah. And then we can check the doc. Yeah, it's a 3-note tree. Then we're just going to copy this for part 3. And then for part 4, we just do this. Then for part 5, we just do this. Then for the lab, we just copy all of this. Wait, let's make sure that these are correct. Okay, yeah, they're all different. Yeah, I wanted to make sure that I didn't double copy anything.
Wait, 1 second. Question 4.
Yeah.
If it's infix. Oh, okay, sorry. My screen share was just lagging. I was like, why is the infix ending on 0016? But it wasn't infix, it was something else.
Oh yeah, that was the postfix one. Yeah, sorry about that.
No, your screen, my screen was just lagging.
Okay, so we got question 5, and then we can go to question 7. And then copy all of this. And put this in the quiz. Do
Does
the
it paste
images?
pictures?
I don't think it does.
Yeah,
Well,
I
we got the
think
source.
You can insert the picture, so you can, I think,
download the
to-
pictures and then
yeah.
insert it.
Okay, yeah, I'll do that. Wait, can I copy these directly into there, or is it not going to like that?
I don't think so.
Okay, yep, I have to upload this. Oh yeah, I can do insert. Okay, yeah, so I'll download these images. Let me download. That's not what I wanted to do. Oh, can I not? Okay, I will just have to do this thing. No.
Yeah, that's pretty much what I did.
And then this is Q7 image 1. And so we'll upload that to the quiz. So insert image. So that's going to be this image. You're going to submit it. Whoa. Okay, yeah, it showed up. That's good. Then we got to do the other 2 images. So let's do that. Actually, can I get rid of this? Okay, snipping. There we go. I'll just save this as a second image. Image 2. And then we go to the quiz. We insert image. You upload the image. Here we go. We submit that. There we go. And then there's one more image that we have to upload. And then that will be it. Yeah, but we can upload this. We put 3, and then we can upload that to the quiz, and then we should be all done. Page 3, submit. And then we have the rest of the stuff down here. So that's question 5, 4, and 3. Then the images are question 2. Then here's question 1.
You might want to number. I don't think we had numbers next to questions 3, 4, and 5. You might want to. Oh, you're just not doing it. Never mind.
Yeah, I'll do it. So here's 3. Here's 4. Here's 5. And then we can just go back up and see everything. So we got first image, second image. We have our prefix. So yeah, we print first. So 0016 should be first. Infix, go all the way left, then print. So that's 009. And then, yeah. And then we end at the right. And then over here, we end at the top because we go left, right, then print. And then question 6 we have here. And question 7 is this. Y'all want me to submit?
That's good.
Okay, yeah. Yeah, and then I'll stop sharing and then I'll end the recording.